Hi grade 11s, welcome to this first pre-session for term 3 of the PUA Saturday school. The next few short videos are to guide you through the pre-lesson activities found in the study guide, which is on ClickUp. Each video deals with one pre-lesson activity so that these video segments remain short to ensure that you engage effectively with them. The pre-lesson activities are designed to help you to be able to make sure you can state Coulomb's law, describe how the electric force changes with relation to the magnitude of the charges and the distance between the charges, use Coulomb's law in calculations, and describe the electric field as a region in space around which a charge will experience a force. Here is the proposed schedule for the time that you should be spending on the various activities, including the online diagnostic quiz, accessing information, learning using simulations, practice problems, and textbook engagement. The total time with both pre-lesson and post-lesson activities and the contact session should take 220 minutes. This session deals with pre-lesson activity 1. You will need a notebook to write in, pens to take notes, a calculator, highlighters to emphasize important things, and a quiet space to work in. For the first pre-lesson activity, you need to access information by going to the physics classroom. Here's the website. I will post the link for you now. As you work through this lesson in the physicsclassroom.com, I'd like you to answer the following questions. What type of force is the electrostatic force? Please explain your answer. What two factors affect the magnitude of the force? That should be not charge. What fundamental rule governs the interaction between charges? Write a mathematical expression for the forces between the charges. Try and use this law in the mathematical calculations in the worked examples that are given. And how does this law compare to Newton's law of universal gravitation? So now on this website, it starts by explaining what is Coulomb's law, and that it is a force that acts over a distance, and it also describes it as forces as a vector quantity. It's very important to understand that, and then there's a rule that governs the interaction between charges. So what happens when two like charges are brought closer together, or what happens when two unlike charges are brought together? The proportionality constant used in Coulomb's law is K, and it has a value of 9 times 10 to the power 9 newtons per meter squared per Coulomb squared. Now, it also explains the mathematics behind using the sign of the charges. If you put the signs into the calculation, and you really don't need to, but a positive and a negative charge, which are unlike charges, will give a negative answer. Negative answer will always indicate a force of attraction. A positive answer will always indicate a force of repulsion. So please remember that you don't have to put the signs in, but you can. But then a negative answer is a force of attraction, and a positive answer is a force of repulsion. Remember, if something is negatively charged, it has an excess of electrons. If it is positively charged, it has a shortage of electrons. And like charges will always repel, and unlike charges will attract. So please make sure you understand the mathematical aspects of using the positive and the negative in the charge. Here they are not indicating a vector, it's just indicating the types of charges. So the key point here is that you can use the positive and negative signs to help you indicate the type of charge. But if you're thinking conceptually, rather use the rule that like charges repel, unlike charges attract. Here are the calculations using Coulomb's law. There are 3 worked examples, and you can look at how the problems are solved. Remember, for example, in example B, nanocoulombs is times 10 to the minus 9. Centimeters must also be converted to meters. So please remember those conversion rules. Here, microcoulombs means times 10 to the minus 6. And here you have to calculate the distance. So please try and work through these examples and see if you can answer them before looking at the solution. For those of you that need a reminder, here are the SI prefixes. So milli is, it tells you that it's 10 to the power minus 3. Micro is 10 to the minus 6. Nano is times 10 to the minus 9. Pico is times 10 to the minus 12, and so on. So it's useful to make sure that you know these different SI prefixes, especially in calculations for Coulomb's law. And then for those of you that might struggle with the conversions, if you want to go from centimeters to meters, you divide by 100. If you're going from millimeters to meters, you divide by 1,000. So here's an easy diagram to help you remember conversion factors when you're going from millimeters to meters and so on. And finally, the page ends by comparing the electrical and gravitational forces.